what we're going to do is just go over what the steps are and how they're different from the steps for a confidence interval. But you'll see that there's 5 steps in writing a hypothesis test, and there's really one additional step than a confidence interval, but they're slightly different. So this is step 1 right here. So if you're not understanding this today, it's probably because you didn't watch the first videos. So formal hypothesis testing in 5 easy steps using yesterday's example. So step 1, basically we have to state what we know, what we have found in our sample, and the type of test that we're going to use. So we did conduct a sample. We sampled 124 couples, and we found that I think 84 of them, I'll double check, 83. So we did a sample and found that 83 out of 124 couples tilted their head to the right when kissing. Okay, and the reason we did that is because we read an article that someone felt that same way. Okay, what we actually assumed though is, hey, really people don't, it's like 50-50, you know, 50% of the people tilt their head to the right, 50% to the left. That's our assumption. But based on this sample, we see that perhaps it's actually more than 50%. Maybe people do favor tilting their head to the right when they kiss someone. All right, in this first statement, we're basically stating that. So at first glance, it appears that the true proportion of couples that tilt to the right, P, is greater than 0.5. Why would we say that? Because our sample is greater than 0.5. Since our P hat, our sample was 0.669. Now, before you actually make this statement, you really have had to think through what your hypotheses were. So there had to be some preliminary work before you did this. You had to, look at your sample value. You had to basically come up with the hypotheses before you start writing this. So at first glance, it appears that the true proportion of couples that tilt to the right is greater than 0.5 because our sample was 0.669. That's how you'll start every hypothesis test. At first glance, it appears that it could be mean, proportion, it could be something of whatever your problem is. And it could be greater than, it could be less than, something like that. So the next statement is very similar to what we did in the confidence interval. We don't necessarily say we're wrong, we just say it's possible that the true proportion is 0.5. And we got this sample because of sampling variability. So it's possible that this was just a fluke sample and it's this high because of sampling variability. That if I were to go out and look at 124 other couples kissing, I may not get something that high. So, but I'm not going to go do that. Instead, I'm going to do a hypothesis test. So to decide, here's the key of this entire statement here. To decide, I will conduct a one sample z-test for P. And you name your alpha level. So you have to name the type of test. This is a one sample. Why is it called a one sample? Because I took one sample of 124 people. And it's a z-test because we're dealing with a proportion, so we use z, and it's for P, the true proportion. And then we pick an alpha level, okay? If an alpha level is not given to you, you pick. It doesn't matter, 0.01, 0.05, 0.10. So if this isn't given, if not given, you choose. Okay, if they don't give you an alpha level, you choose it, and you have to state it in your initial step 1. Okay, step 2 is the new step. So step 2 is to state the hypotheses. So step 2 is to state the hypotheses. It's important that you label the hypotheses with H sub 0. This is called the null hypothesis. It's what we assume to be true. What we assume to be true. It has nothing to do with the sample. Okay? I would just assume that people have no preference as to which way they tilt their head when they kiss someone. It's 50-50. to make, so you have H with a little zero, then you have a colon, and then you have to state your statistic, your true value. It could be mu, in this case it's P, the proportion. The proportion of people who tilt to the right when kissing is equal to 0.5. Okay, that's what I think. That's not necessarily what I think, but we would assume that. What I think based on my sample is called the alternative hypothesis. The alternative hypothesis. And it's what I think based on my sample. My sample was greater than 0.5, 50%, so I will say the alternative is that the true proportion of people who tilt to the right when kissing is greater than 0.5. Okay, now step 3 is check your conditions. Check your conditions. These are the same conditions that we had when we were doing a proportion for even when we were doing confidence intervals. So the randomization condition, is it a random sample of couples? Well, it's not stated, so we just have to assume it's random. Is it less than 10%? We assume that 124 is less than 10% of all couples. And is it a large enough sample size? This is the n times p is greater than 10 and n times q is greater than 10. And they're both greater than 10, 62 and 62. And you're always using the hypothesized value. I'm always using the hypothesized value for my n times p. So this would be 124 times 0.5 and 124 times 0.5, p and q. But it's always the hypothesized p. All right, step 4 is your calculation. Okay, step 4 is your calculation. Now, you always start your calculation out with a probability. We are trying to find the probability. This stands for the probability that I get an observed value as high or higher, as high, as we can even say as extreme as our sample. So the probability that I get an observed value as extreme as our sample, assuming the null is true. Okay, the key to the hypothesis test is what we are always assuming is that this null hypothesis, whatever our null hypothesis is true. So it's always based on the difference between our sample and the null. So this is the probability that our sample is as extreme or more extreme than our assuming the hypothesized value is true. So the probability that p hat is greater than 0.669. This is the first time you used your sample value in the problem. So then we are going to change our p hat into a z-score. Change our p hat into a z-score. So that formula is actually right down here. The formula for the z statistic, z is equal to p hat, my sample value, that's what the p hat is, minus the hypothesized value. So the sample value minus the hypothesized value over the standard deviation of p, which is the square root of pq over n. 1 minus p is q. So the calculation is shown right here. 0.669 minus 0.5 divided by 0.5 times 0.5 over 124. The only place you use your sample value is in the sample value, the p hat, in your calculation. Otherwise, you're always using the hypothesized. So now we have that this whole calculation works out to be 3.76. So now that we've changed it to z, another word for z is normal. We have changed it to a normal model with a mean of 0 and a standard deviation of 1. I'm going to draw my normal model here. I'm going to put this z-score on my normal model, which is at 3.76. So what we're saying is, if the true proportion is 50%, this sample value that I got is almost 4 standard deviations above the mean. So the probability that it's even farther that or higher should be pretty small, shouldn't it? So now we can do, from here we have to do NCDF, normal CDF, and based on my picture, my lower bound is 3.76. My upper bound is infinity. My mean is 0, my standard deviation is 1. If you're dealing with a z-score, the mean is always 0, the standard deviation is 1. So when I do that on my calculator, second distribution, NCDF, I already have it in here, I get, now look up here at this answer. Some people are in such a hurry to write the answer down, they would write 8.5 and go, the probability is 8.5. How do you know that's wrong? Well, yeah, but if you didn't even look at that, how do you know that 8.5 is wrong for a probability? It's over 1. Probabilities are between 0 and 1. So if you write a probability down more than 1, you are guaranteed wrong. So this p-value is actually, the -5 means it's 0.000085, which is really, doesn't it say it's approximately 0? If I asked you to round that to 2 decimal places or even 3, it'd be 0. So the probability of this happening by random chance is none. Okay? Now step 5, we have to learn to make a conclusion. So the way you make a conclusion, after you get the p-value, this value here, 0, is called the p-value. So the p-value is the answer you get from step 4. The p-value is step 4's answer. And the p-value is always compared to the alpha. So my p-value was 0. What alpha level did we have at the beginning? 0.05. Now we put a symbol in there. It's either less than or greater than. What symbol makes this true? 0 is blank, 0.05. Less than. Okay? When the p-value is less than alpha, we reject the null hypothesis. Reject it. We throw it away. Well, what was our null? Our null was that people don't have a preference. 50% kiss to the left, 50% kiss to the right. We got rid of that. So we have basically said instead that there's a tendency for people to tilt their head to the right when they kiss, based on our sample. So there are 2 ways to make conclusions. This is the key thing. This is the page you can always go back to in your notes to help you make a decision on a hypothesis test. Any hypothesis test, and we'll be doing lots of hypothesis tests in the next chapters 21 through 25, 20 through 25. So if you remember, at step 5, you always take your p-value and you compare it to alpha with either less than or greater than. There's only 2 decisions to make. Either the p-value is less than alpha, and then we reject the null. We throw the null hypothesis away, and we conclude that whatever happens in the alternative is, we don't just say it's true, we just make a conclusion that it's possible that more people prefer to tilt their head to the right. If the p-value is greater than alpha, then we fail to reject the null. You never say accept the null. We only fail to reject it. So I keep the null and say, well, there's not enough evidence for me to say otherwise. So I'm going to say that it's 50-50. So we already went over the formula for the z-statistic. And the book uses a different procedure. Use my 5-step procedure. When checking and calculating, when checking conditions and calculating the standard deviation of p hat, we always use the true value. So like right up here, when we check the conditions, we use 0.5, the ones from the null. We couldn't do that in confidence intervals because all we had was the sample value. We weren't comparing it to anything. In a test, we're comparing our sample to some set value or a true value. And if any of the conditions in step 3 are not met, you just state your concerns and proceed with caution, but you never quit the problem. All right, so on the next page, we're going to do we're going to write out our own hypothesis test. And then you are gonna do one on the board.